بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we will see logarithmic functions part 4, which is limits. Now miscellaneous part. Now a miscellaneous problem. We have a function f defined on 0 open plus infinity as f of x is x plus 1 plus ln x over x, and c is the representative curve of f. The first part asks to prove that the line x equals 0 is a vertical asymptote to c. Remember, x equals a is a vertical asymptote to c if and only if the limit of f of x as x tends to a is infinity. So here we have to find the limit as x tends to 0 plus of f of x. So try to do it alone. While here we need to find the limit as x tends to 0 plus of f of x in order to get x equals 0 as a vertical asymptote. Let's go on. We need the limit of this function as x tends to 0, and if we substitute, we get 0 here, 1 here, and this is negative infinity, so we get negative infinity. Thus, x equals 0 is a vertical asymptote. Remember, the limit of ln x over x as x tends to 0 plus is negative infinity. This was memorized by heart before. 2a, determine the limit of f of x as x tends to plus infinity. Also take your time. Okay. Now what is the limit of f of x as x tends to plus infinity? We just substitute. We get the limit of this quantity. And this is plus infinity. Remember, this part tends to 0 when x tends to plus infinity. It was memorized by heart. And this part is plus infinity. Well, D is the line with the equation y equals x plus 1. The question is to prove that D is an oblique asymptote to C at plus infinity. Also remember, a line y equals ax plus b is an oblique asymptote to C if and only if the limit of f of x as x tends to infinity is infinity and the limit of f of x minus y of the line as x tends to infinity is 0. Now we know from before that the limit of f of x as x tends to plus infinity is plus infinity. So the first condition is satisfied. We still need to satisfy the second condition. So we need the limit of f of x minus y of d as x tends to infinity, and this limit should be equal to 0. Try to do it alone. Let's see. The limit of f of x minus y of d as x tends to plus infinity. This is the limit of, this is f of x, it should be taken from here. And then y of d, this is y of the line d, which is x plus 1. And we try to simplify it a little bit. X plus 1 and x plus 1 are eliminated. And we still have ln x over x as x tends to plus infinity. And this is 0. Thus, the line D is an oblique asymptote to C at plus infinity. Now, another miscellaneous question. F is a function defined on 0 open plus infinity as f of x is x ln x plus x minus 1. C is its representative curve. Remember, IAB is a limiting point or endpoint if and only if the limit of f of x as x tends to a abscissa is equal to b, which is the ordinate. So in this case, to verify that the point e0 negative 1 is a limiting point, we need to find the limit as x tends to 0, and this should be negative 1. Try to find it alone. Now the limit of f of x as x tends to 0 plus, Remember, we find here the limit as x tends to 0 plus because it's open at 0. This is the limit of x ln x plus x minus 1 as x tends to 0 plus, which is nothing but negative 1, because the limit of x ln x as x tends to 0 plus is 0. This was memorized by heart. And the limit of x is also 0 by substitution. And what remains is negative 1. Thus, E0 negative 1 is a limiting point to C. Now, Rami, Rima, or Amir. The question is to calculate the limit as x tends to 0 plus of ln x over minus 2x minus 1. Rami, I will use substitution. So, by substitution, Rami got plus infinity, and he said that this happens because we have negative infinity over negative 1. Rima, I will use my memory. She used memorization and said that the limit of this quantity is 0. Amir, I will use L'Hopital's rule. Amir used L'Hopital's rule. He derived the numerator alone, the denominator alone, simplified to get minus 1 over 2x, and this is negative infinity. Well, what do you think about the 3 persons? Let's discuss very quickly. What Rima did is she used her memory, but in fact we didn't memorize such a limit before. So what Rima did is not accepted even if the answer is correct. Let's see what Rami did. Rami used substitution. Ln 0 plus is negative infinity. And minus 2x minus 1 when x tends to 0 is also minus 1. And negative infinity over negative 1 is positive infinity. So this is correct. What Amir did is that he used L'Hopital's rule, but pay attention, if we substitute here, we get negative infinity over negative 1, as what we got here for Rami's answer, and negative infinity over negative 1 is positive infinity, and this is not infinity over infinity or 0 over 0 to be able to use L'Hopital's rule. Remember, dear students, we cannot use L'Hopital's rule unless we have infinity over infinity or 0 over 0. So simply L'Hopital's rule cannot be applied here. And Rami's answer is correct, Rima's answer is not correct, and Amir's answer is not correct. So here as a summary, remember, the limit of ln x as x tends to 0 plus is negative infinity. The limit of ln x as x tends to plus infinity is positive infinity. The limit of ln x over x as x tends to 0 plus is negative infinity. The limit of ln x over x as x tends to plus infinity is 0. And the limit of x ln x as x tends to 0 plus is 0. And all of these limits could be memorized by heart. Now, if we want to calculate a limit, we use substitution. We either get an answer or we get an indeterminate form. Now, in the case of infinity over infinity or 0 over 0, we go on applying L'Hopital's rule. In case we get plus infinity minus infinity, we take a common factor. We either take x or ln x in common. And in case we get 0 times infinity, we apply reciprocal.